Hi everyone, welcome to Geek Coding Academy. Today we'll start the series of collection framework in Java. So let's start. So I have prepared a very comprehensive course for this collection framework. So let's see the table of contents, what I designed. First we'll see what is the introduction for the collection framework and what are the core interfaces of the collection framework and list interface and its subclasses, set interface and its subclasses, queue and dequeue interfaces, map interfaces and its subclasses, and comparison between list, set, and map. And the part 2 section, what is utility classes in a collection framework and how to iterate through collections, concurrent collections, generics and the collection framework, immutable collection, streams and the collection framework, best practices with the collection framework. So these are all very very vast, like complete. I have prepared these lecture. So in this video, we'll see about introduction of collection. In our coming up videos, we'll cover all these table of contents, guys. So and also I covered all the basics up to exception handling in my previous videos. If you're not watched that video, please go and watch that video prior to this because this collection is somewhat like an little advanced. So if you don't know about basic syntax and fundamentals of Java, please watch my previous video prior to this. Okay. So let's start. So what do you mean by collection framework? So first of all, understand like what is the need of Java program. So Java or any program we write to handle a data, right? We have one input type of data. We need to um, we need to manipulate that data or we need to make use of that data for some logic and we need to provide some output data. So finally, the programming language is for handling a data, handling and manipulate of data for the uh, use case or for the requirements. Okay. Suppose I have a large set of data, so I need to handle that data. So as a developer, I need to write a logic to do that. So what Java team has decided, they will provide some set of default data structures or default classes so that if I use that, I can make use of them to manipulate my data or to manage my data, suppose. So this will actually reduce us the developer time and also it will increase the code performance because those already defined classes are built on top of like very optimized way so that the performance will be increased and also it will save a lot of time to as a programmer. So let's see what is collection framework. So collection framework means is set of classes and interfaces that implement commonly reusable data structure. Okay. So it was introduced in Java 2 version, and it provide more efficient way to work with a group of objects known as a collection. So group of object means group of data known as like we called the group of data, we can call it as any collection of data. Okay. So collection are used to store, retrieve, manipulate, and communicate these data. Okay. So you have a basic idea, rough idea, like collections in Java means like there will be already a ready-made classes. If you use that, we can able to easily manage our data. Okay. So if you have that idea, we'll go to that next. Uh, so what is the hierarchical representation of a collection framework? This entire collection framework starts from these two interfaces only. First, it will start from collection interface and it's another one is a map interface. So entire this collection framework, how it has built is it starts from these two interfaces. Okay. So the collection interface, there were some of sub interfaces. For that, we have a lot of classes which are implementing these interfaces. And for map, we have some of the classes, child classes. For collection, we have some of the child classes. So using the child classes, we can manage our data easily. Okay. So why we have two different, one is collection and one is map, two interfaces. Why? Because like the type of data we are storing for these two interfaces is different. Like for a collection interface, we have it is dealing only with a single data at a time. Like there will be like collection of data which is of type single unit. But in map interface, the pattern of storing data is little different. In map, we store in terms of a key value pairs. Like key is one object and value is one object. Like at a time, two objects we are mapping. So that's the reason like this collection type of data and map related data will be grouped under these two interfaces. So we'll see what all come under collection interfaces. Okay, collection interfaces in Java is the root of collection framework that I told. Like two roots are there. One is collection and one is a map. This collection is one of the root of Java collection framework hierarchy, and it is present in the part of Java util package. Okay, that's a folder, Java util package, and it defines basic method. Like it defines basic method that all collection classes means sub interfaces for this, like list, set, queue. So what all those? Don't worry, guys. Like I will teach more depth on these subclasses or sub interfaces. So these are all like whatever interfaces or classes come under this collection interface. This collection interface will give you a particular like a framework so that the subclasses or sub interfaces will inherit those, will override the method defined in this collection interface and give a logic for that. So as a developer, if I choose a particular um, collection data structure, a particular collection concept, I can handle my data. Okay. The collection interface is not used, like this collection is an interface, even though we are not directly creating an object for this, but the child classes will create an object and this collection is just like a reference, like it's a parent for all that. In our previous video, while talking about interfaces and inheritance concepts, I have told this relationship. You can watch that video in my YouTube channel. So the key feature of the collection interface is it will give a generic it is a generic interface. So means like it's a root of all collection framework. It's one of the root of collection framework. So we can work with object of any type with this and iterable interfaces. This is one of the important concept I need to tell here. This collection interface, there is one parent for it that is called an iterable. Okay, one of the parent for this collection interface is iterable interface. So this collection is a child class of that iterable interface. Because of that, in iterable interface we have that iterator that is used to it just like a for loop. It is used to iterate over our collection of data. So that feature will inherited to this collection interface. So let's see the what are the methods. I already told what are the methods defined in these collection interfaces. We'll see some of the basic methods. I'll make it into a categorized wise. Like basic method, like size, it will return the size of the it will return the number of element in the collection is empty. We are checking that our collection is empty or not, like whether data is there or not. Contains, add, remove, and iterator. So there is all the basic methods defined in this collection interface. So all subclasses who will be the part of these collection interfaces or who will be child of these collection interfaces will have this uh, by default. We'll have inherit all these methods so that it will be useful when we trying to manage our data. So what are the bulk operations defined in this collection interface? We'll see like contains all, add all, remove all, retain all, clear. So what all this is? Contains all means it will check the collection contains all element from a specified condition. Like suppose if I provide a one collection and it will I'll call this contains all and provide another collection. So what it will check is that collection which I provided will be available in this present collection. So I know you guys like little bit confused because if you are watching this for the first time, so all these things I will be doing practically so that you will understand. So that's why I am not go deep into the all these method and method definition and everything. I'll go on an overview. This is just like an overview video. In my future video, I'll go in depth. Okay. This add all. What is add all? I'll go. But you think of like these are all the default methods. Like sorry, these are all the methods are defined in collection interface level. Okay, remove all, retain all, clear. For array related operation, we have two methods defined in collection interface. One is to array, means collection we can able to convert it back to an array, and array we can convert back to an collection. We'll see that in my future videos. Like and also the to array for runtime specific type. Okay, so this is a overview of complete hierarchy of collection interface. So we have a collection interface. Like on below of it, we have a list, set, and queue interfaces. All these green color are interfaces. which is will be the child interfaces of this collection interface. So these sub interfaces will have child classes like array list, linked list, and vector. This vector has one more child class called stack. If you come to set, we have a child class called ash set, link set, and tree set. But here once again, one point is there, like this tree set is not directly a child of this set. It is there will be in between another two interfaces will come. One is a sorted set and navigable set. After that, the tree set will be the child of that. And for queue, we have a priority queue. And after that, there is a one interface also for a child of this queue, that is DQ. For this DQ, we have two child classes, array DQ and linked list. Okay. So what are these? I'll tell you. This is a collection interface. It has some default methods which we saw in the previous slides. All these default methods, all these generic methods. It will be there up here. There we return one more interface list, suppose. So it will have this all these generic, by default it will come up here because it is a child interface of this interface of the collection interface. So all the methods will come here. Along with that, for a list, we have a specific methods defined here that will be added to this. The Java developers who have designed this has added to it. And these child classes, for example, that array list will override all the methods defined in list and collection. Along with that, it has its own specific class specific methods also. Similarly for all class. So it's just like a completely neatly structured, so that based on what data type we are handling, so what data we are handling, we can choose accordingly. Okay. So similarly, all the concepts. So this is all about collection interface. Let's see what you mean by map. Okay. The map interface is Java is also a part of collection framework. I already told in collection framework, collection and map. So used to store key value pairs here. There we are just storing individual objects in a collection. Here we are storing in the format of key value pairs. So unlike collection interface, that is handling a collection of individual objects, here in map interface works with a pair of objects. Okay, where a key and a corresponding value. Okay, key is the map must be unique. Like sorry, key in map must be unique. Key always should be unique. Okay, for example, we have an array, like we have one complete set of data that is of type map, means the key value pairs will be there. The keys should be unique. Keys, there will be no duplication, but value may be duplicated. Value can be duplicated. The most common implementation of map interface, the most common child classes of this map interface will be like hash map, linked hash map, and tree map. So we'll see what are the generic methods defined in this map interface. Okay, before that we'll see the characteristic of this map interface. Like I already told, it's the storage format is different compared to collection. Here the format is key value pairs. Like the map stores entries which consist of key values only. Like there will be unique keys. A map does not allow duplicate keys, but a value associated with these keys may be duplicate. That can be duplicate. And null handling. So some implementation, suppose like an hash map allows one null key and multiple null values, but others like a tree map which does not allow null keys. Okay. So we'll see the what are the generic methods defined in this map interface, like how we saw in the collection interface. Similarly, like this, like put, get, remove, contains key, contains value, size, is empty, clear. These are all default methods available in this map interface. So we'll go one by one deep. Like once we advance into this topic, I'll go one by one deep. So this is an overview video. So we'll see overview of it. I'm not going in depth because it may confuse you guys, because collection framework is a little tricky for a new developer. So that's the reason, like in our next video onwards, like I'll go with a practical example so that you can understand completely. And also like a bulk operation, we have this put all methods. These are all methods, generic methods available in this map interface. Like views, for view purpose, we have this many generic methods like key set, values, entry set. Okay. So we'll see the hierarchy of this map interface. Like map interface is the interface. We have a default generic methods you saw in the my last slide. Yeah, these are the methods. So for these methods, only the method declaration will be there in the interface. That the body or implementation will be given under the classes which are implementing the interfaces. Means the child class duty to give an body for the method declared in the is parent interface. Okay. So what are the child classes for this map? Ash table, and it's one of the legacy class. Ash map, which is widely used for maps, and linked ash map and tree map. Okay. So these are all the four classes we used child classes of map. So map is not part of a collection hierarchy. Okay, because like in collection framework, it starts from these two interfaces, collection and map. All other data structures are under the collection, and the data which is of type key and value pairs are under map. So map is not a part of collection hierarchy because it is go like side by side, but a separate interface for a key value pairs. Okay, and ash map is most commonly used implementation due to its performance characteristic. Performance wise, the ash map is very good. For ordered maps, linked hash map, tree map are useful. Okay. Map.entry is used to access key value pairs during iteration. So when you want to iterate through key value pairs, basically like most recommended way is map.entry. Okay. So we'll see what are the benefits of using this collection framework. So I already told it reduces the programming effort by providing useful data structures like list, set, map. The framework saves time for developers as they don't need to write their own implementation from scratch. Suppose you have a data, one like for example, you have a data which having a key value type of data, or you have an individual object type of data. If you're trying to suppose like we saw some of the default like generic methods like size and also iteration, iterating over each object by object. For that and all, if you want to write in a your own logic, it will be very burden for a programmer. So it takes a lot of time. So in order to avoid that, a Java team give it a very well structured collection framework. Okay, if you use this properly, we can able to handle any type of data like without worrying about performance or space. Okay. So it increases the program speed and quality. The framework includes highly optimized data structure and algorithm, which can lead to performance improvement in Java application. And interoperability, like which consists of an API across different type of collections. The framework ensures that collection can work together seamlessly. That means like a type of one collection data, we can able to convert it to a type of another type of data, and vice versa. And flexibility, like collections can be used for various types of data. We can use these collections or these predefined classes for various type of data, including a generic type or non-generic versions. Okay. So guys, this all about overview of collection framework. I know it's like some of you guys may think it's a um, bit tough, like if you are seeing this collection framework for the first time, but don't worry, like once we advance through the course, through the practical examples when we go through, it will be very easy. So once you know these, it's just like if you get an input data, and by looking at the input data you come to know like which class, which collection class I need to use. That's it, like, and you can manage the data more easily. So in I'll take up some of the practical real-time examples, and I'll teach like in my next video we'll see more, dive deep into what are these interfaces available in this collection framework, like list, set, queue, dequeue, and what is the map, and everything, and classes related to this list, set, map, queue, DQ, everything. We'll see, and what specific specific methods available in these classes, and also like when we want to use these classes, or what type of data we need to use the classes. Everything I'll discuss in my next video. So till then, this is just like an overview of course and overview of this collection framework. So thank you for watching, guys. I hope you enjoy you understand, like you got some little information from this video. If you got any little information from this video, please like this video and subscribe to my channel. Please share this video to your friends and colleagues, and I'll meet you in my next video. Till then, keep watching, keep learning. Thank you. Bye.